All right, so we're still on lesson 3 and we're going to tackle examples 3 and 4. So we're looking at a geometric sequence 12, 18, 27, and it's asking us to find the general term formula. So we need two pieces of information. We need the value of u1, the first term, which is 12. We also need the common ratio. It's not immediately obvious to most people what the common ratio is to go from 12 to 18 to 27. So what I would do is take two terms and divide them. I'm going to take 18 and divide it by the term in front of it. So 18 divided by 12 can be simplified to 3 over 2. Just to check and make sure we've done that correctly, let's do the same thing with the next two terms. So 27 divided by 18. That can also be simplified to 3 over 2. So here's our common ratio. 3/2, and our u1 is 12. So here's our general term formula. un equals u1, so 12, times common ratio r, 3 over 2, to the power of n minus 1. There's our general term formula. We want to use that formula now to find the value of the 10th term. So we know that n equals 10, and we want to find the value of the 10th term, u10. So we'll use our general term formula for that. u10 equals 12 times 3 over 2 to the power of n minus 1. So 10 minus 1, which is 9. That's going to give us 12 times 3 to the power of 9, which is 19,683, divided by 2 to the power of 9, which is 512. If we multiply through and simplify that, we end up with 59,049 over 128. I hope most people would recognize that this would most definitely be a paper 2 question. You would not be expected to do that without your calculator. Part C says, is 114 a term in the sequence? So we need to test that. We're going to put in 114 as a term number, as a term value, and then we'll see if we can find a term number that's an integer. So we'll set that equal to our general term formula. And we have to try to solve for n. The first thing that you probably would want to do is divide both sides by 12 to get rid of that coefficient. 114 divided by 12 gives us a simplified fraction of 19 over 2 equals 3 over 2 to the power of n minus 1. From here, you would probably recognize that this is most likely not a term in the sequence. However, the only way to be sure would be to use your calculator. You could also use logarithms, but we have not yet covered those. Most people would choose to use their calculator here. You would want to put 19 over 2 into y1, 3 over 2 to the power of x minus 1 into y2. You'll want to graph those, and here's what it would look like if you had a window, a standard window. Here's 19 over 2. So there's y1, went straight across your screen. And then y2, 3 over 2 to the power of x minus 1, is going to come in like this. It's going to be an exponential function. And what you're looking for there is when they're equal to each other. So you're looking for this intersection point right here. So in order to find that, you need to use second, trace, intersect. And what you'll find there for an x value, or in other words, your term number, is 5.80. Therefore, what we conclude is that 114 is not a part of the sequence, because our x value, or our term number, is not an integer. 114 is going to be somewhere between the 5th term in the sequence and the 6th. But it's certainly not a term in the sequence itself. Finally, for example 4, it's giving us 3 consecutive geometric terms in a sequence. So there's term 1, term 2, and term 3. And it's asking us to find the value of k that's going to make that sequence geometric. So what we need to use here is a little bit of logic. We know that if it's a geometric sequence, then it has a common ratio. And you find the common ratio by taking one term and dividing it by the term before it. So I could find the common ratio by taking 3k and dividing it by k. I can also find the common ratio by taking 20 subtract k and dividing it by 3k. I've set up a bit of a system of equations here. Probably want to simplify my left side, noticing that they both have a common factor of k before I get started here. So I end up with 3 equals 20 subtract k over 3k. Probably want to try not to have any fractions there. Maybe think about multiplying both sides by 3k in order to cancel these out. I end up with 9k equals 20 subtract k. Then I want to gather all of the k's onto one side. I end up with 10k equals 20. Dividing both sides by 10 leaves me with k equals 2. I would probably plug this back in to make sure I do indeed have a geometric sequence. So I check my work. My first term was k, so 2. My second term was 3 times k, so 3 times 2, which is 6. And my third term was 20 minus k, so I end up with 20 minus 2, which is 18. I need to check and make sure this is actually a geometric sequence, which means there's going to be a common ratio. In order to get from 2 to 6, I've got to multiply by 3. And to get from 6 to 18, I also have to multiply by 3. So I know that this is geometric.